So we're going to continue our conversation in solving systems of equations. In part 1, we solve systems using the graphing method. And remember, there's 3 possibilities when we solve. We're either going to have one solution, no solutions, or an infinite number of solutions. So we've already talked about graphing, and now let's talk about the other 2. We're going to use the substitution method, and we're also going to learn about the addition, which is also called the elimination method. So let's start with the substitution method. In solving using the substitution method, what we're going to do is solve for one of the 2 variables in either the first equation or the second. I'm going to solve for x in the first equation. So in the first equation, we have negative 1x plus 7y equals negative 16. So I'm solving for x. So I'm going to subtract 7y from both sides. That gives me negative 1x equals negative 7y minus 16. And then I divide each term by a negative 1. So this gives me x equals 7y plus 16. I'm going to put that inside parentheses. So what we're going to do is go back and use the second equation, the 3x minus y equals 8, and substitute 7y plus 16 in for x. So we have 3. Instead of x, we're going to put in 7y plus 16, and we have minus y equals 8. Distribute, so 3 times 7y is 21y. 3 times 16 is 48, minus y equals 8. Combine like terms, so 21 minus 1 gives us 20y, plus 48 equals 8. Now subtract 48 because we're solving for y. This gives us 20y equals negative 40. And then we're going to divide both sides by 20. So y would equal negative 2. So for our answer, we know our y value is negative 2. We have to find our x value. So the easiest way to do that is to go back to this equation, x equals 7y plus 16. So x equals 7y. Well, we know what y is. We just found it to be negative 2. So x would equal 7 times negative 2, which is negative 14, plus 16. So x would equal 2. So our solution for this system would be 2, negative 2. And again, you could plug in 2 for x and negative 2 in for y, and it should check in both of the original equations. So next, we're going to use the addition or the elimination method to solve. So in the addition or elimination method, what we want to do is add the 2 equations together and eliminate either the x or y variable. So in some instances, we're going to have to multiply one or both equations to make that so, because when we look at this equation, or these equations, I should say, 10 is not opposite of 5, because if I add 10 and 5, that gives me 15. So that's not eliminated. And if I add 7 and 6, that gives me 13. So neither would be eliminated. So what we're going to do is multiply one or both equations so that either the x or the y is eliminated. So I'm going to rewrite the 2 equations. So it's your choice. So in this case, I'm going to eliminate the x. So in order for them to be eliminated, I have to make the coefficients opposite. So what I'm going to do is look for a number that both 10 and 5 go into, and they both go into 10. So my first equation already has 10 as a coefficient, so I need to make the coefficient of x in the second equation -10. So in order to do that, I would have to multiply it by -2. But I don't just multiply that term, I multiply the entire equation. So I'm going to rewrite the first equation, 10x plus 7y equals 14. And now I'm going to multiply that whole second equation by -2. And that gives me -10x minus 12y equals -24. Now I'm going to add the two equations together, and now it does what I needed it to do. The 10x and the minus 10x will cancel out, leaving me with only one variable. So now I add 7 and -12. That gives me -5y, and 14 minus 24 is -10. So then I'm going to divide both sides by -5. So y equals +2. Now I have to find my x value. So I'm going to go back to my original equations, either one. So I'm going to take the first equation, the 10x plus 7y equals 14, and substitute 2 in for y. So we'd have 10x plus 7 times 2 equals 14. So we'd have 10x plus 14 equals 14. I'm solving for x, so I need to isolate. So I'm going to subtract 14 from both sides. So 10x would equal 0. And of course, when I divide by 10, 0 over anything is 0. So my x value would be 0. And again, you can check your answer by plugging 0 in for x and 2 in for y into both equations to make sure that your answer is correct. Next example, again, we're going to continue on with the elimination method. So here I have 2x minus y equals 3 and 3x plus 2y equals 15. So if I added the equations as they are, neither x nor y would be eliminated. So what I need to do is multiply by whatever it takes to either make the x's opposite or the y's. I'm going to again make the x's opposite. So I look at 2 and 3, and the common multiple, not factor, multiple of 2 and 3 is 6. So I need to multiply the first equation in order to make the number or my coefficient in front of x 6. So I'm going to multiply that equation by 3. When I do that, that gives me 6x minus 3y equals 9, because I multiply everything. Now, my second equation, I need to make the coefficient opposite. So what do I need to multiply 3 by to give me a number opposite of 6? -2. So now when I multiply, -2 times 3x is -6x. -2 times +2y is -4y. And -2 times 15 is -30. So when I add, again, it's doing what I want it to do. It's eliminating one of the two variables. And that gives me -7y equals -21. And I'm going to divide both sides by -7. And a negative divided by a negative is a +3. So my y value is 3. I need to find my x value now. So what I'm going to do is go back to either one of the two original problems, and I'll take the first one, the 2x minus y equals 3, and substitute 3 in for y. 2x minus 3 equals 3. I'm going to add 3 to both sides. So 2x would equal 6. So when I divide both sides by 2, it tells me that x is 3 as well. So my common solution for this system of equations is 3 and 3. So when I look at this, the solution to the system, I would put in the box 3 and 3. Now it says, which of the statements below is a good explanation? So think about when we graph. If I have one solution, that's where two lines will intersect. So in this case, my possibilities are the graphs of the two equations represent the same line. That's not true, or I'd have an infinite number of solutions. So in this case, that would be if I had an infinite number. I have a single solution. So the second possibility says the graphs of the two equations never intersect. If they never intersect, then there's no solution. And that was where our lines were parallel. The last possibility says the graphs intersect at one point. If it intersects at one point, that means we have one solution, which we do in this case. So that would be the answer that we would choose. So now we have another system to solve. We have 7x minus 8y equals 7, and negative 14x plus 16y equals negative 14. Again, if I add the two equations together, neither the x nor the y would be eliminated. So I need to multiply to make either the x's opposite or the y's. I'm going to do the x's again. And so when I compare 7 and negative 14, I know the common multiple is 14. In other words, both 7 and 14 go into 14. So since my second equation already has a coefficient of negative 14, I need to multiply this first equation so that my coefficient is positive 14. So I'm going to multiply by 2. When I do this, 2 times 7x gives me 14x. 2 times negative 8y gives me negative 16y. And 2 times 7 gives me 14. Remember, you multiply everything by that number. I didn't have to make a change to the second equation, so I'm going to copy it down just as it was in the original problem. And now look what happens. My x's are eliminated, exactly what I wanted, but also my y's are eliminated. So on the left-hand side, that leaves me 0. On the right-hand side, I have 14 minus 14, which also equals 0. So since my variables are eliminated, I'm not going to have a single solution. I'm either going to have no solution or an infinite number of solutions. Anytime we solve and the resulting answer is true, because 0 does equal 0, I would have an infinite number of solutions. If this were a false statement, this gave me 0 equaled some number other than 0, then I would have no solution. So again, let's look at our possibilities. So in this case, it says A, the solution set is. That's not true because we don't have a single answer. We have an infinite number of answers. So that would be choice B, because our resulting answer, 0 equals 0, is a true statement. So what would that mean in terms of a graph? If we have an infinite number of solutions, that means the graph would have been the same line. Our next example incorporates fractions as coefficients. So this is something that bothers most students. So what I recommend doing, although it's not the only way, is before I deal with the elimination, I eliminate the fractions and then compare. So what you're going to do is look at each problem individually. So when I look at this first equation, I have 3/4 x minus y equals 1. The common denominator, or the least common denominator, is 4. So what I'm going to do is multiply each term by 4. So when I do that, in the first term, the 4's reduce, and that just leaves me with 3x. I have minus 4y, and then that's going to equal 4. So in the second equation, I do the same thing. So I'm not eliminating variables yet. I'm just eliminating the fractions so I can do this problem with less difficulty. So here the only denominator is 5, so I'm going to multiply each term by 5. And when I do that, that gives me 20x. Here the 5's reduce, minus 4y equals 5 times 28, which is 140. So now I need to eliminate either the x or y. So this is where I would do the comparison. In this case, it looks like it'd be much easier to eliminate the y's. So they both have coefficients of -4, but I need one to have a +4. So what I'm going to do is multiply the first equation by -1. And all that's going to do is change the signs. So this becomes minus 3x plus 4y equals -4. So when I multiplied by -1, it changed all the signs. So the second equation, I don't need to make a change at all. So now I add the two equations. And again, it's doing what I want it to do because one of the two variables is going to be eliminated. -3 plus 20 gives me 17x. And -4 plus 140 gives me 136. So now you're going to take 136 and you're going to divide by 17. So x would equal 8. So now I need to find the corresponding y value. So I'm going to choose one of my two equations. I'm going to choose the 3x minus 4y equals 4 and substitute 8 in for x. So I have 3 times 8 minus 4y equals 4. So this is 24 minus 4y equals 4. Subtract 24 from both sides. This will give me -4y equals -20. And when I divide both sides by -4, a negative divided by a negative is a positive. So that would give me a +5. So my common solution would be 8, 5. Remember, your x value comes first and then your y value. So again, in filling in the answers, we have 8, 5 inside parentheses because it says as an ordered pair. That's important. So what does that mean? That means that the graph intersects at one point. Now let's get into word problems. Don't be afraid, these word problems aren't very difficult. And so remember that we're dealing with solving systems, so we're going to have two separate equations. So this says 93 passengers, okay? So sometimes it's written in words and not in symbols. So we have 93 passengers, that's important, that went from city A to city B. Tickets for regular coach seats cost $118. Tickets for sleeper cars cost $298. So we have two variables. So R is going to be regular coach, and S is going to be your sleeper. Okay, it's the number of passengers. So here we have 93 passengers total. So the number that were in regular coach plus the number of passengers that were in the sleeper equals our total number of passengers, which is 93. Okay, notice there's no dollar amounts connected to any of these. You want to be consistent. So in the second equation, this is where the dollar amounts will come in. So it says regular coach costs $118. So it's 118 times R plus sleeper is 298. So it's $298 for every sleeper car passenger. And that gives us our total receipts, which is $20,694. Okay, so notice 118 is a dollar amount, 298 is a dollar amount, and 20,694 is also a dollar amount. 93 passengers is not a dollar amount, so the 118 and the 298 should not be in that equation. So now we have a system of equations. You have two choices, or three really. You can either do graphing, you can do substitution, or you can do elimination. So if we're using the elimination method, we need to eliminate the R or the S. So if we eliminate the R, we're going to multiply this first equation by negative 118 so that the coefficients are opposite. So this would become negative 118R minus 118S equals 93 times 118, which is negative 10,974. So I didn't make any change to the second equation. So now I'm going to add the two equations together. So negative 118R and positive will cancel out exactly what I wanted it to do. So then I'm going to add the negative 118 to the 298, and that's going to give me 180S. And then I'm going to take the negative 10,974 and add it to the 20,694. And that gives me 9720. Then I'm going to divide that by 180 because we're solving for just S. So the number of sleeper car passengers would be 54. So to find the regular coach, we come back to one of the two equations. The first one seems a little bit easier to solve. And we're going to substitute 54 in for S. So R plus 54 equals 93. And then subtract 54 from both sides. So 93 minus 54 would give you 39. So you'd have 39 in regular coach. So all of these you're going to set up using a system of equations, and then you're going to solve using one of the methods that's easiest for you to use. So the next one I'm going to set up but not work out, because you're going to work it out solving it as a system. And you'll see these are even easier than that last one. So it says Jen Butler has been pricing speed pass train fares for a group to New York. 3 adults and 4 children. So it's going to be as simple as writing exactly what you see. So 3 adults plus 4 children equals $128. Then the next sentence says 2 adults plus 3 children equals $91. So again, we have a system to solve. So you want to eliminate either the A's or the C's by multiplying by whatever it takes to make them opposite. Without working it out completely, I'll show you what I mean. So if I wanted to eliminate the A's, I find a multiple that both 3 and 2 go into, and that would be 6. So I need to make one of them positive 6, so I'd multiply this first equation by 2, and I'd make the other one negative 6 by multiplying by negative 3, because positive 2 times positive 3 is positive 6, and negative 3 times 2 would give us a negative 6. Next example, very similar. So it says on Monday, Louis picked up 5 scones and 2 large coffees. So 5 scones plus 2 large coffees will equal the $16.36. On Tuesday, Rachel picked up 6 scones and 7 large coffees, and she paid $28.05. So again, you see we have a system of equations. So again, you're going to multiply both equations to either make the S's opposite or the C's, and then solve. Our last type word problem is a little bit different. So what I recommend is being consistent on how you set these up. So here we have a distance problem. So we know the formula for distance. If you don't, the formula for distance is time times the rate equals the distance. In other words, if you travel 2 hours at 50 miles per hour, you would have traveled 100 miles. Okay, so now let's read the problem. It says, against the wind, a small plane flew 715 miles in 2 hours and 10 minutes. The return trip took only 1 hour and 50 minutes. What was the speed of the wind, and what was the speed of the plane in still air? So we have against the wind and with the wind. So let's look at rate first. So we're going to let P equal the plane in what we call still air. That means if it were a perfect day, no winds blowing, the rate of the plane would be the same. So if you have wind, we're going to let W equal the speed of the wind. So when it says against the wind and with the wind, if a plane's flying into a wind, it's going to slow the plane down. If it's flying with the wind, then the wind's going to push the plane faster. So now, against the wind, the rate is going to be the speed of the plane minus the wind. With the wind, it's going to go faster, so it's going to be the speed of the plane with the help of the wind. So in every single problem, what I do first is I set up a table and I just write against P minus W with P plus W. And then it's easy to put in the distance. So in here it says that the distance is 715 miles. So you've filled out already 2/3 of the table. Now the next part's a little bit trickier because they're dealing with hours and minutes. And when you're measuring speed, it's miles per hour or kilometers per hour, not per minute. So in this case, we need to express time in terms of hours. So it says, against the wind, it took 2 hours and 10 minutes. So 2 hours and 10 minutes is 130 minutes. So we put 130 over 60 to convert that to hours. The return trip took 1 hour and 50 minutes. So an hour is 60 minutes, and another 50 minutes gives us 110 minutes. And again, converting it to hours, we divide by 60. So at this point, you have a couple of choices. One choice is to distribute these fractions times each one of these variables. In other words, multiply 130 over 60 times P and W. And then on the second one, multiply 110 over 60 times P plus W. But I want to offer a solution to make it a little bit easier. So just like we talked about before, when we solve an equation where the coefficient is a fraction, we can multiply by its reciprocal. So what I'm going to do is multiply both sides by the reciprocal of that time. So I'm multiplying the first one by 60 over 130, and I'm going to multiply the second one by 60 over 110. So when I multiply by a reciprocal, remember it reduces to 1. So this is 1p minus 1w now. Because remember, this reduces to 1, and when I distribute the 1 times each one, I get 1p minus 1w. Now, on the right-hand side, what you're going to do, depending on what type of calculator, you're going to take 715 times 60 over 130. So for those of you with just a scientific calculator, you take 715 times 60, and then you'll divide that answer by 130. And that should give you 330. So notice how simpler this problem has become. So now notice there's no fractions and the numbers are small. So for the second equation, when I multiply by the reciprocal, again, it reduces to 1. And when I distribute that 1 times each one, that becomes 1p plus 1w equals, I'm going to do the same thing. I'm going to take 715 times 60 and then divide that answer by 110. Okay, so now look how much easier the problems become. I recommend doing that on every single time you do these distance problems. Eliminate this number on the outside by multiplying it by its reciprocal. And now we're going to solve the system using addition. Look at what we have, and this will happen every single time if you follow this method. Look at the W's, negative 1W and positive 1W. That will be eliminated when we add. So all I'm going to do, I don't have to make any change to either equation. I'm just going to add straight down. So the W's are eliminated. That gives me 2p equals 720. Now I'm going to divide by 2. And p equals 360. What does p represent? The speed of the plane in still air. So now I still have to find w, so I go to either one of the two equations here. So I'll take the second one, the 1p plus 1w equals 390, and I substitute 360 in for p. So I have 360 plus 1w equals 390. I'm going to subtract 360 from both sides, and this leaves me with w equals 30. And what does w represent? The speed of the wind. So the speed of the plane in still air is 360, and the speed of the wind is 30. Again, my recommendation is when you're setting up the problem, write against and with, write your p minus w and your p plus w, and put in your distance, and then put in your time last. If you follow these steps, it's much easier to solve this type of problem.